Hi, and welcome to the second video of our summary series on trigonometry. And so again, this summary series doesn't do a deep dive into any of the trigonometry. It just covers the basics and makes sure you are up to date with everything you pretty much need to know for the exams. Alright, so what we're going to do here is introduce the cos diagram and just see where the letters come from. So first thing I'm going to do is I'm going to draw a 30-degree angle in here. Okay, so that should be roughly 30 degrees. Alright, now let's just write in 30 degrees here, so 30 degrees. Okay, so as we can see, we've got a unit circle here. That means it's a circle of radius 1. So we can see x goes from -1 to 1, y goes from -1 to 1. And since its radius is 1, the hypotenuse of any triangle we draw in here will have a length of 1 because it is a radius. Alright, so what we want to get to is the sine, cosine, and the tangent values of any angle. So first thing I'm going to do is, if we have this 30-degree angle here, this line, what we can do is we can say, well, if we draw a vertical line from here, so that's not really a proper vertical line, but bear with me. This value here, we know that cosine of 30 degrees will be our adjacent side divided by our hypotenuse, which is length 1. Alright, so and since it's length 1, we're dividing by 1. That means this length here, that'll just be our value for our cosine, because adjacent divided by 1 will just give us adjacent. And since we know this is length 1, the complete line, we can just measure this distance from 0 to there. And this value will be the cos or cosine of 30 degrees will be equal to square root 3 over 2. And we're not going to measure that obviously now. I don't have a ruler for the screen, but you can measure that by yourself and just find out it will be roughly equal to that, even if you just measure with a ruler correct to the nearest millimeter. Right, then we'll do the same for sine, and the sine value is the opposite divided by 1, so that'll just be the opposite. And this opposite length, obviously that will be the same as drawing this line back to here and finding that value. Now what is this value? This value will be a half, halfway between 0 and 1. So we can say sine of 30 degrees equals a half. Now that is a really ugly 0. Let's just improve it slightly. And for tan, now tangent is a little bit more interesting. As you know from the graphs, that's always the problem child. We will continue our line here up until we get to this tangent that we drew right next to the circle. So it's parallel to the y-axis. And then from there, we'll draw that back to our y-axis and read off that value. Okay, so that value, we know that tan of 30 will be equal to 1 over the square root of 3. And these values you can obviously check on your calculator just to make sure. And now I'm just going to quickly go through the angles in the other quadrants as well. So that was the first quadrant. The second quadrant, we'll go draw a 30-degree angle here. So that means we have 150 degrees, right? If this is a 30 degree here, that means the whole angle across will be 150. So let's just write that in 150. And in the third quadrant, we'll have, if we draw a 30-degree angle in here, we'll get, let me just write in 30 again, 30 degrees there. Whoops. Will give us 100 and... we go all the way across, that's 180 plus 30, so that'll be 210 degrees. 210 degrees. And I know it's looking a little bit messy, but that's fine. I might fast forward some of this in post-production. And finally, in the fourth quadrant, if we draw a 30-degree angle in here, that will mean, again, let's just write in 30 degrees. So what does that mean? That's just 30 degrees less than a full 360. Right, so if we go all the way around, that'll give us 330 degrees, right? 30 less than the full revolution. Okay, perfect. So we've already done the first quadrant. We've seen sine 30, cos 30, and tan 30. Now let's do the second quadrant. So here we have sine of 150, because 180 minus 30, and that equals, yep, you guessed it, exactly the same as what we had in the first quadrant, right? If we draw that back, that's 1/2. Cos of 150, so cos 150, that equals what do we see here? We see that's the same distance away from 0, but this time it's negative. So it's negative square root 3 over 2. And for tan 150, what do we get here? Now this is a little bit interesting. So we've got this line, but there's no tangent we drew here. What we do is we continue this line in the opposite direction until we get there, and then draw it back. So that'll be this value. So again, we see it's the same distance from 0 as we had in the first quadrant, but now it's a negative value. Okay, so tan will be negative 1 over square root 3. Good. And then we get to the third quadrant. Here again, we do the sine value. So if we draw that back, we'll see that's a half, but this time negative. So sine of, and what's 180 plus 30? That's 210. So sine 210 equals negative a half. Let's do the cosine. Cosine of 210, that equals, if we go here, see that's exactly the same as the second quadrant. So that's negative square root 3 over 2. And the tan of 210 degrees, the tangent to 10, that equals, again we draw this line, keep going this way, so that just measures up and fits directly onto the first quadrant. So that's the same value as we have over here, and that is positive 1 over square root 3. And finally the fourth quadrant. So the fourth quadrant, we have sine of our angle, so this would be 360 minus 30, that gives us 330 degrees. That's equal to, if we draw that back here, we see that's the same as the third quadrant, that is negative a half. Then we do cosine of 330. So the cosine of 330 degrees, we draw it back to the x-axis for the adjacent side. That's the same as the first quadrant, so that's just square root 3 over 2. And finally, the tan of 330. Tangent of, almost wrote tangent, 330. So for the tangent, we've already seen that's the same as quadrant 2, because we keep drawing this line up until we get to the tangent, draw it back to the y-axis, and we read off that value. So that's the same as what we had in the second quadrant. That is negative 1 over square root 3. Oops, really ugly 3. Okay. So now, what we wanted to do with all of this is we wanted to see where which functions or ratios, as we want to call them, are positive or negative. So in this first quadrant, this graph looks really messy, but that's fine. I'm sure you can all follow. In this first quadrant, which things are positive? Well, all of them. So that's why this quadrant gets a big A for all things are positive. In the second quadrant, only the sine is positive. The other two are negative. So we get a big S for the sine function being positive in this quadrant. In the third one, only positive one is tan, so we get a big T. And in the fourth one, only positive is cos, or cosine, so we get a big C. And we see this is where the cast diagram comes from, by telling us which things are positive in which quadrants. Okay, and one last point I want to make before we end this short video is just to see what happens as we go along, as we move from 0 all the way around to 360 and then start the cycle again. What happens to the different ratios? Well, we can see, as we've already drawn some lines in here, if we had sine of 30, we saw the value was a half. If we increase this, and we increased it to maybe 45 degrees, we'll see the sine value will increase, right? It's going bigger. It'll be 0.707. If we increase it to 60 degrees, we see it gets even bigger, and that'll be sort of the same values we had here for cos. So it'll be square root 3 over 2. And we increase it even more, it gets closer and closer to 1, until we get to exactly 90 degrees, where the value will be 1. Then as we start increasing even more, let's say 120 degrees, the value starts decreasing again for sine. So we go for sine, we start at 0, then as we increase all the way up to 90, it goes to 1, all the way up to 180, it goes to 0, right? The y value here is 0. All the way to 270, it goes to negative 1, and then a full revolution at 360, it goes back to 0. So we see that works out when we look at the sine graph, and we'll look at the graphs later on, but just as a quick illustration, if we have the value 1, the value negative 1, we see sine starts at 0. As we get to 90 degrees, it gets to the value 1. As we get to 180 degrees, it gets to the value 0 again. All the way down to 270, it gets to negative 1. and all the way to 360, it gets to 0 again. So if we put in the values 0, 90, 180, 270, and 360. And then we can see, obviously, the circle just repeats. So that's why the graph just keeps on going like this. And it'll be the same for cos, it just has a different starting point. And for tan, there's a little bit of a difference because you've all checked, if you type in tan 90 on your calculator, what do you get? Tan 90 equals, and you'll probably get some type of error on your calculator. And if we look at this graph, it'll make sense, right? Because for tan, we can continue this line or extend this line until we reach the tangent line and draw it back to the y-axis. So we can see if we increase it all the way up to here, then it'll take a long time before it reaches this line, and draw it back and you'll get some really big value. But what if you draw it exactly at 90 degrees right here? Then we see this line will be parallel to this line, and they will never meet. So there's no way you can meet and then draw back to the y-axis, and that's why you get an error. Alright, so that's pretty much it for this video. Important thing is just that we can see which quadrants have which ratios being positive and negative, specifically the positive ones for the cos diagram. And in the next video we'll look at how to use this to solve some problems. Thanks for watching, and join again on the next video.